So my right hand is broken, and I also want to do some consistent notes, and I can't really write well with my left hand, and this little guy, doesn't really help me either. So we're going to do some notes here, and hopefully it'll make sense. You can go watch it multiple times. Completing the square is a really important feature of what we do. So to start with, we can get x squared minus 36 equals 0 by taking the square root of both sides. And you'll notice here they do this weird thing with the absolute value bar equals 6. Well, normally what happens is we usually only take what's called the principal or the positive square root of a number. But there is always two square roots of a number. So the point is, 9 is 3 times 3, but it's also negative 3 times negative 3. So both 3 and negative 3 are square roots of 9. So if we go back and look over here in the example, they've got x equals plus or minus 6. That's showing that 36 has a positive square root and a negative square root. I'm going to just make sure this is focused really well. Okay, so those are my first two things I want to mention. Principal square roots, we know they're normally positive, but in this case we can do negative and negative as well, positive and negative. All right, next example. So we've got an example like this, and we can solve it if we've got a perfect square to start with. X squared minus 4x is a perfect square, and this is what we did in class the other day. We actually found the perfect square, so I'm just going to throw that in the middle there. They've got the x squared, x minus 2 squared. We can show this in an area model. X minus 2 times x minus 2 is x squared and minus 2x and 4. So that's where the x minus 2 squared is the same as x minus 4, x plus 4 equals 3. And then we take the square root of both sides. So when we take square root of x minus 2 squared is x minus 2, so x minus 2 is both plus and negative, a square root of 3, which is a number, plus or minus square root of 3. In the same way, the square root of 36 was plus or minus square root of 6. And then I just need to finish solving that. If x minus 2 equals plus or minus that, then x, when I add 2 to both sides, is 2 plus or minus the square root of 3. So the answer is 2 plus the square root of 3 and 2 minus square root of 3. And this seems a little weird to most students, but we can actually even think about this in terms of real numbers. The square root of 3 is about 1.73. It's not exactly that, but it's close. So in reality, our solutions are 2 minus 1.73 and 2 plus 1.73. Or if I actually figure that out, it's about 0.27 and about 3.73. So both those should basically work in that equation. Not exactly, because we've rounded it, but pretty close. So if I actually check that, if I take those two numbers and plug them back in, 0.27 squared, so I'm plugging it back into my original equation here, minus 4.27 plus 0.4 plus 4 is 2.99. So it's really close. It's only off because of rounding. And when I plug in that other number, I get almost exactly the same thing. So this number, while it looks weird, is the exact number. If I was able to plug that in exactly into this, I would get the left-hand side would actually come out 3. So the challenge that I've got written down here is, can you actually check using 2 plus square root of 3 plugged into that equation? Obviously, 2 minus square root of 3 would be a challenge as well. Can do it. You're going to get some square roots as you work along the way. You're going to actually have to square this, and you get kind of an unusual number, but it will ultimately work out perfectly to 3. So there's your challenge. All right, moving on here. Next page. We talk about the pattern for squaring a binomial, and just some very quick reminders, maybe not reminders, maybe first time, but a monomial is simply a term that doesn't have any fractional powers, that has a real coefficient, so like 2x squared or 1/2 n to the 5th, or just a y, or just a 1 would be a monomial. A binomial is when I've got those two terms connected with a plus or minus, so like 2x squared plus 1m to the 5th, or y plus 1. Those are both binomials, bi meaning 2. And then trinomials, which is really what we're when we square two binomials, we get a trinomial usually. So an example of a trinomial is 2x squared plus 5x squared plus 3. And once again, these are all polynomials, poly meaning many. So combinations of monomials here. All right, I'm going to double check my focus here. All right, so they're just showing you, hey, they've got this pattern, which when I've got something squared, there's always two of these in the middle, and whatever that number is gets squared. So this number right here is always twice whatever this number is over here, or said another way, this number here is always half of whatever this number is. So that's our pattern, and we did this in class the other day. This is the pattern we used yesterday, and the pattern we used yesterday basically said we found half of the b, if it's written this way, so half of whatever that number written in front of the b is, we do that, and then we square the result of that, we find out whatever half that is to square it, and we add it to the x squared plus bx. And so what this would look like down here, if I had x squared plus 14x plus c, then this is very much like we did yesterday. We take half of it, and the way it looked yesterday, it was like this. We found half that number, which was 7. Let me scoot this over. We found half that number, which was 7. We put it in our little area model, and then we're like, oh yeah, 7x and 7x, that'll give us the 14x that's in the middle. But then the third term that I don't know is 49. So this is just a more methodical way to do this without the area model, and just know that, hey, I'm always going to take half that number, square it, and then add it on, and that gives me a perfect square. That would be x, this in this case would be x plus 7 squared, which is what it says down here. Okay, so now that we've reviewed all that, we can actually go through and complete the square to solve an equation. So I want to solve this equation, x squared plus 6x minus 16. So to do that, I'm going to need to do something. I got to figure out what x is. So the suggestion is, the very first thing is we're going to keep the problem simple, okay? My next note that I want you to squeeze in somewhere is keep the problem simple. So we're only going to look at x squared and 6x. So whatever is added or subtracted on here, we're just going to move it to the other side. So just to get it out of the way. Okay, so I've got another little note there, is in that next spot there, we're going to move what I'll call the ones term to the other side. And this is what we did right here. We had the minus 16, we added 16 to both sides, we now have 16. All right, next step is I need to complete the square. So for this particular example, I need to find it. If I've got it, oh, there it is. We're going to complete the square there. If we complete the square, x squared and 6x, we're like, oh yeah, take that number, chop it in half, that's 3. So 3x and 3x, which means our other number is going to be 9. So x squared plus 6x plus 9, that's our completed square. Now notice this other 9 over here, okay? So I got another little note here. If I add 9 to one side of the equation to complete the square, which that's the completed square, I need to add 9 to the other side of the equation to keep the equation balanced. I've got that underlined, because if you just add 9, it is no longer the same equation, and you're going to get the wrong answer. So we can add the 9 there to complete the square, but to do that, we've got to offset it by balancing it and adding 9 to the opposite side. All right, that is a complete square, so we're going to rewrite that as a completed square. So it's x plus 3 squared. That's equal to 25 when I combine the 16 and 9. I then take the square root of both sides, and that's both positive and negative 5. X plus 3 is both positive and negative 5. I've taken the square root, so that's that radical has that exponent has gone away because of taking the square root of both sides. I don't show it there, but essentially I could have in this step right here written, here, let's see if we can do it with my bad hand, taking the square root of that side, taking the square root of that side, and now that's what I just did, plus or minus 5. So I got negative 3 plus 5 and negative 3 minus 5, and so my answers are 2 and negative 8. So my answers or solutions are 2 and negative 8, and I don't need to check this, but I could check it. And, you know, if I plug in to my original equation, 2 squared plus 6 times 2 minus 16, that is equal to 0, as well as negative 8 squared, which is 64, and that's negative 48 and negative 16. Those all cancel out to 0 as well. So this totally checks. Okay, almost done. We've got a longer example here. And the only thing I want to point out are the longer, couple things on the longer example. The longer example, 2x squared minus 9x plus 8. They tell you over here, but I'm going to reemphasize it here. For this completing the square system to work, the x squared term must have a coefficient of 1. Okay, it doesn't there. So to make it 1, I'm going to divide everything by whatever that is. So I divide everything by 2, and I've got x squared minus 9 halves x plus 4 equals 0. So now I can do my completing the square, but I can't do this process that I'm showing you if I don't have a lead coefficient of 1 there. So that's the first thing I'm going to do. All right, the next thing I'm going to do here is I'm going to get that 4 out of the way. I'm going to keep it simple. I'm just going to look at the x squared minus 9 halves x. So I'm just going to minus 4 from both sides, get it out of the way. All right, now this next part is a little complicated. So what's happening here is 1/2 of 9 halves is 9/4, and 9/4 squared is 81/16. So that's where that 81/16 came from, is I'm completing the square. I'm taking half that, squaring it. But then to do it there, I've got to do it to the other side. So that's where the 81/16 comes in. It's completing the square, but then I've got to do it to both sides of the equation. All right, then we're going to write this in perfect square form. That's what we're doing right here. We're like, oh, that right there's a perfect square. It's x minus 9/4 squared. Then we're going to take the square root of both sides. So that's what we did in the next step. We took the square root of both sides. Square root of that side, it's squared, so the square root, it goes away. It's just x minus 9/4. Square root of this side is square root of 17. Square root of 16 is 4, so that's, I got square root of 17 on top, but just 4 on the bottom. And then finally, I've just got to add the 9/4 to both sides to get the final solution. So I got a negative 9/4 on this side. If I add 9/4 to both sides, it ends up on the other side. So I have 9/4 plus or minus the 17, root 17 over 4. And then, so this is my solution. 9 plus the square root of 17 over 4, and 9 minus square root of 17 over 4. Now these numbers can be approximated, but if you actually plug these numbers into that exactly, you could do a bunch of algebra and show that this would always work out.